Okay, let's hope this works. All right, so I told you how to use remove a little while ago. So there's one, perhaps the most famous instance, somebody typing in RM minus RF star was somebody who was working on Pixar's Toy Story 2. And so someone, the way Pixar used to work back in the day was that everybody would be working on a Unix workstation. And they would all be networked into some server somewhere that would have access to all of the files for the movie. Someone, no one knows who, apparently typed in RM minus RF star, probably in the root of their of the Toy Story 2 directory, and deleted all of the files belonging to the movie. If you read the story, sure. So if you want to follow the link and read that story, the link's right there. It's actually quite a funny story. There's a whole sequence of things that go wrong. And Toy Story 2 was almost the movie that never was. All right, so be careful when you're messing around on your computers if you're trying out stuff, especially if you're removing or copying files, and especially if you're on a Mac. If you're in Windows and you're on Ubuntu, it's not a big deal. You delete all your stuff. You only lose stuff for CISC220. If you're on a Mac and you delete your home directory, you're going to lose everything that's on all your files that are on your Mac. So be very careful about that. All right, so today's lecture is about arrays in Bash. Is there another one? I don't remember if there's another lecture after this one for Bash. Let's see. Arrays, functions. Okay, so we have to do functions still as well. Okay, so Bash does have arrays. It has a one-dimensional array type. It uses an integer index to access the array elements. It also has an associative array, which you know, what was that? Which you know either as a Java map or as a Python dictionary. We don't, well, I don't talk about associative arrays here. You use them basically the same way you use a Python dictionary, though. So I'm just going to talk about the indexed version of arrays. So the interesting thing about a Bash array is that it uses an index. It starts at 0, the smallest index that you can use is 0. But all that means is that 0 is the smallest legal index. It doesn't mean that your array actually starts at index 0. So in Bash, you can create an array and you can start using the array at element 12 if you wanted to, for example. Right? So there are no elements 0 through 11, but now your array starts at 12. It gets weirder. You can even skip elements. So you could start at 12 and then go to 15 and then go to 35 and then go to 197, et cetera, et cetera, et cetera. And there's no elements between 12 and whatever the next index is. So the arrays are a bit unusual compared to other arrays or lists that you've seen in other languages. The syntax to assign a value to an array is similar to Python's list or Java's array. Right? So you use array, square bracket, and then the index, square bracket, if you want to assign a value. So this little cell here, right? We're going to make an array called ARR. We're going to set element 0 of that array to the string hello. When you want to access the element of the array, so when you want to get a value from the array, it's the $brace. You have to use $ and brace to dereference the array. Right. So to get array element 0, it's $brace array 0 inside of the braces. And that works or should work just fine, right? So there we go. Okay, now it's really easy to make the mistake of forgetting the $brace, right? And so you might just write $ARR. Okay, so here I'm going to unset array. So unset removes the variable ARR from the environment. Right. Now I'm going to make an array again. Right. So here I make an array starting at index 5, and I assign that value weird. And now I'm going to try to print out the element, except now I forget to use the braces and the index. So here I just print out or I just access $ARR. Okay. And in Bash, what that does is that prints the value of ARR 0. Right? It doesn't print the value of ARR 5, right? It prints the value of ARR 0. Right? So that's what it means. So if you just use the name of the array and dereference it, you always get back the 0th element of the array. You don't get the first element of the array, right? You get the 0th element of the array. It's strange, that's just the way it works, right? Okay, now if I go ahead and set the 0th element of the array to strange, right? And then again, make the mistake of dereferencing the array element, just using the name of the array. Now I get the output strange. If you actually want the, if you actually want to get a value of a particular element, use the braces and then use an index. Right. So this script here is going to print out the empty string AR element and then nothing, because AR0 is unset. Here it's going to print out element strange, and then here it's going to print out element weird. Any second now. Oh, it's really slow. What's going on? Strange element. There you go. Right. So strange, but that's the way it works. Okay, so remember, you need the braces. If you don't put the braces in, weird stuff happens. Right. So if you write $ARR square bracket I square bracket, what happens? Well, $ARR, that's just whatever the value of ARR0 is. Right. Square bracket I square bracket is just the string square bracket I square bracket. So if I set the the 0th element of the array to strange, and then write $ARR square bracket I, notice that Jupyter is trying to help you here, right? It's showing you that the index is showing up as part of the string and not actually an index. Right? What you end up with here is strange square bracket I square bracket. Something's going on with my computer. Right? So you don't get strange, right? You get strange square bracket I. Right? If you want to print it out correctly, all right. If you want to print it out correctly, you need the braces. Right. Actually, that's not good. That's going to print out nothing because I is undefined. So there, right. And that'll print out the first element now. Okay, so if you want to make an array, you can just create the array variable, slap an index after it, and keep on going. That'll make the array automatically for you. There's several different ways to declare an array in Bash, however. So you can use the command declare with the A option to declare an empty array called X. Right. So declare minus AX makes an array X that's empty. Here, you can use declare again. Minus A makes an array. Right. Now you can use the syntax Y equals and then round brackets and then a list of elements. Right. So this is Bash's array initialization syntax. Right. So round brackets, list of elements that will make an array having those elements starting at index 0 in this case. So if I print out Y0, Y1, and Y2, I should get 10, 20, and 30. Any second now. I don't know what's going on with my computer. Something funny is happening. It's very slow. Okay. You don't actually have to declare the array though. So declare is completely optional. You can just go ahead and make the array. Right. So here, array 1 is the array that has one element, right? It's the string hello. Array 2 is an array that has 5 elements, the strings 0, 1, 2, 3, and 4. If you want to, you can specify an index to assign the value to, right? So array 3 is an array that has one element whose value is goodbye. The element in array 3, though, is at index 1, right? So square bracket 1, we're saying assign to ARR3 square bracket 1, right? Array 4 is very weird, right? So array 4 makes an array that has 3 elements in it. The array element at index 0 is weirder. The element at array index 1 is weirdest, and the array element at index 100 is weird. Right, so this is perfectly legal in Bash. I don't know of any good use for it, but it's legal. Right. There we go. So it runs, no errors. All right, if you want the number of elements in the array, then it's similar to the syntax you use for a string. Right, so dollar, brace, and then the number sign, followed by the name of the array. And then, unlike a string, you throw in this square bracket at square bracket syntax here. Okay. So the syntax is unusual. Again, that's just the way it works in Bash. So same arrays from before. Right. And then I'm going to print out the number of elements in each array. Right. Again, using the syntax $ brace hashtag name of the array square bracket at. Right. So here I should get 1, 5, 1, and 3. Case. 1, 5, 1, and 3. Yep. Okay, so what is this at subscript doing? Right, so the at subscript and the star subscript, where did we see this? We did this one. Oh, $at is the command line parameters, right? And $* are also the command line parameters. Right? So the at and the star, when you use them as an quote unquote index for an array, they result in an expansion of all the elements in the array. Right? So if you don't quote the expansion, then using the at and the star result in the same thing. Right? So both of these result in the expansion of the array elements as a list. Right? So array element 0 comes first, then there's a space, array element 1 comes next, then a space, then array element 2 comes next, and then a space. Right? So you get a list containing the elements of the array, nothing is quoted. Right. So this is fine if you know that your array doesn't contain any strings that have special characters in them. Most of the time, though, you don't really know what's in the array. Right. In those circumstances, you probably want to quote the elements of the expansion. Right. So if you quote $array at, then that produces the expansion of the array elements, but each array element is quoted. Right? So in other words, no string breaking, no space word splitting will happen on the individual elements of the array. So this is almost always what you want to do. It's not always what you want to do. You might come up with some strange situation where this isn't what you want to do, but this is almost always what you want to do. Okay, so if you use the star notation instead, then what that does is it produces a single string containing all the elements of the array separated by a space. Right, so the effect is to produce the string, right, where each array element where each array element occurs one after the other, followed by a space, and then the whole thing is quoted. Right, so you get one string, the entire string is quoted. All right, so let's look at some examples here. So here we've got an array containing 3 elements, right? A dog, a cat, a fish, right? Notice the elements have spaces in them, right? The strings. So I'm going to loop over that expansion, right? So remember what that expansion is. That expansion in this case is a dog, a cat, a fish. Nothing's quoted, right? So nothing's quoted. So when you print this out, you're going to get a, then dog, then a, then cat, then a, then fish on separate lines. Right. Everybody got that? Right. So we didn't quote the expansion, so nothing in the list it gets quoted. Again, same thing, except this time we use at. Again, we're not quoting the expansion, so nothing gets quoted in the expansion, so we should expect the exact same output. Good. All right, now we quote the expansion, and we use add. So here, this gives us each element of the array quoted separately. Right, so in other words, we get a dog quoted, space, a cat quoted, space, a fish quoted, space. Right, so now we're going to get 3 strings on output, or 3 lines, I guess. And now finally, the last one, right, we use star and we quote the expansion. So this produces one giant string, a dog, a cat, a fish, and then the whole thing gets quoted. Right, so there's only one element in the expansion, and you get 1 string on output. Okay. You almost always want this one here. Right, you almost always want to quote the at expansion. All right, so if you use the array in a sane way, then when you make the array, you're using the indexes 0, 1, 2, 3, and so on and so on and so forth, right? If for some reason you've decided to use the array and you're using and your indexes aren't necessarily in order or they're not necessarily sequential, then you need some way in order to get the actual indexes that you've used. So if you want to get the actual indexes used by the array, then the syntax is $, then brace, then exclamation mark, and then the @ expansion here. Right, so that'll produce a list containing a list. Yes, it produces a list of the indexes that are actually assigned in the array. So here that should be element 0. This should be elements 0, 1, 2, and 3. This one is just element 1, and this one is elements 0, 1, and 100. And I'm actually not sure what order they're going to come out in. So let's see what happens. So 0, good. 0, 1, 2, 3, good. 1, and oh yeah, I guess it sorts it. So 0, 1, and 100. So that gives you a list of the indexes, and now you can loop over the indexes if you need to loop over the elements of the array. Right. So the indexes are useful if for some reason you need to loop over the indexes of the array. Right. So here's the first 5 months of the year. Right. I'm going to get the indexes. Right. So using the exclamation mark. Right. So this is going to be 0, 1, 2, 3, 4. And then I'm going to access each element of the array using an index here. Do I not need $I there? Hang on. I think there's a mistake. I need $I there, I'm pretty sure. And so this should be there we go. Right. And so that loops over the elements of the array, this time using an index. You don't have to loop over the elements of the array using an index, though, right? You can always use the quoted @ expansion, and that'll give you a list of the elements. Okay, if you want to join 2 arrays in Bash, you can do so quite easily. Right? So to join 2 arrays, you use +=. Now, this only works if you have 2 arrays, right? So if you try to add an element to the end of the array, this doesn't work. Right, so to join 2 arrays together, right, array 1 and array 2, then what you do is you take array 2, you expand it with the @ expansion, and then you quote it. Right, so that gives you a list of quoted elements, and then you turn it into an array using the round brackets. Right, so that's what that's doing right here. Right, that's taking the elements of array 2, expanding the array 2, all of its elements out, each element individually quoted, and then making an array out of those values. Do you have to do? Yes, I think you have to do that. Okay, so if you want, so to concat the 2, so after that, you'll have array 1 will have all the elements of array 1, followed by all the array elements of array 2. So A, we set index 100 to 0. Then I've got, sorry, what's that?
What is unset?
Unset removes A and B from the environment if I've already used them. I don't remember if there's already an A and B up here, so I just unset them to make sure there wasn't an existing array. So we're going to set element 100 of A to 0, and then we're going to try to concatenate 5, 6, and 7 to the end of that array. So that line there is the one that does the concatenation. Then I'm going to print out all the elements of the array. And I'm going to print out all the indexes used in the array. So I'm pretty sure this gives you 0, 5, 6, 7, and then 100, 101, 102, 103. 0, 5, 6, yeah, that's what it gives you. Right. So when it concatenates these elements onto the end, it just uses the next sequence of next available sequence of indexes. Okay, if you want to append a single element to the end of the array, then all you do is you turn the single element into an array. Right. So you take your element that you want to append, you quote it to make sure no string word breaking happens. Right. And then you turn it into an array by wrapping it up in round brackets. Right. And now you can concatenate the element to the end of the array. Right. So if my month is the array January through April, I can concatenate the month May to the end, as long as May is an array. Like, oh, like that. There you go. Okay, so interactively reading elements into an array. So the read command, which we've seen already, we used read the other day to read a file. You can also read into an array, which is occasionally handy. So read by default reads from standard input. So if you do read -a ARR and press enter, it'll actually read stuff in from. You can then type stuff in your at the prompt and enter stuff in at the prompt. Right. If you want to, you can even give a message. Oh, sorry. So if you use the -p option with read, you can give a string. That's the prompt to prompt the user. And then -a ARR will read the elements that the user types in into an array. Right. So for example, we can run this in my terminal. So we'll just do read -p. So the prompt is, what's my prompt? Enter a list of elements. That, and then -a AR. Oh, sorry. Okay, so -p is prompt. -a is make an array and read the elements into an array. So if I press enter here, you get the prompt and you can enter in your list of elements. So 1, 2, 3. Oh, sorry. 3 and 4. Okay. And then if I print out AR, put it like that. Oh, what did I do? Oh, there's a missing quote. Sorry. Oh. Oh. Okay, so echo $ARR at like that. Right, you get 1, 2, 3, and 4. Okay, so reading lines of a file into an array, this is also occasionally useful. So in the, I guess in the previous lecture, we used read and we read in a file one line at a time, right? And then did something with the line as we read in the file. Instead, you can read the entire file into a single array. Each line of the file goes into the array as a separate element. Right, so the command map file, which is also called read array, right? So these are both the same command, right? Read array and map file. We'll read one or more lines from standard input, storing each line as a separate element as the array. So you use the -t option. So when you use the -t, that removes the new line character from the end of each line before storing it in the array. If you don't use -t, then you get the new line character at the end of each element, which is usually annoying. Right, so you want to get rid of that new line character. Okay, so we've got this file here. This is the same file that we looked at last class, right? So it's this list of students, right? So it's comma separated values. So student number, last name, first name. There's just 3 students in the file. So you can use map file or read array to read in that entire file all in one line, right? Rather than writing a loop, which we did in the previous lecture. Right. Once you've done that, you can go ahead and then do something with each student. So for example, any second now, here we go, right? And so now you end up with the following output, right? So each line of the file is now available to you as an array element, and now you can process the array elements to access the values or to access each line of the file. Right. So for example, you can go into each element of the array, check whether or not it's a comment, right? If it's not a comment, you can extract the student number, last name, first name, right? And then do whatever it is you need to do with the array. All right, so that's bash arrays. They're a bit odd. You have to get used to the syntax. That's the difficult part with working with bash arrays. Otherwise, they're just like arrays or lists in Python and Java. Any questions about arrays? All right. So this is the last bash lecture, I think, because all that's left to talk about are functions. So like most other programming languages or most other imperative programming languages, you can write what's called a function in bash, right? So a function is just like, well, it's similar to a Python function or a Java method, right? It's got a name, you can pass it parameters. The return value is kind of weird in Bash. There isn't really a return value. I'll show you how to deal with return values. But otherwise, it's a similar idea, right? You've got this named block of code that you can repeatedly use just by calling it by name. The big differences are how you pass the values to the function, how you return values from the function, and the way that variables are scoped between the function and the rest of the script. So those are all very different compared to the languages you've worked with so far. So to write a bash function, it comes in one of two forms. Either you write function, name of the function, brace, brace, right? And the commands of the body of the function goes inside the braces. Or you use the function name, round bracket, nothing inside the round brackets, right? Even if the function has parameters, you don't put anything inside the round brackets. Brace and brace, and then the body of the function between the braces. The first form is legal, but it's not portable across shells. So in other words, it's bash specific. Not just specific to bash. There's probably a few other shells that use it. The second form, though, that one there, works in all shells. So you should probably use the second form if you're writing a function. The space or new line after the opening brace and the new line before the closing brace are important, right? So that new line right there, oops, sorry. Okay, so the new line after that brace and the new line before that brace, it turns out those are important, right? If you don't have them, the shell won't interpret your function properly. So if either is missing, then a syntax error occurs because the shell can't determine if the brace is the delimiter for the function or if it's part of an identifier. So you have to be careful about that. Right, here's an example. So this is using shell check, right? So if you run this in shell check, it will actually tell you that there's an error here, right? Notice that I've got a brace and then no space after the brace, right? So Bash actually gets confused by this lack of space. Name, go. So let's just run over to shell check. All right, let me make this bigger for you. There we go. So, Bash. And so, sorry, what did I have before? Where'd it go? Let me see, just copy this. Right there. And so give it a second, right there, right? So shell check tells you that you need a space after the brace. So you need space after that brace there. And then that error should eventually go away. There you go. Right. So you need some white space after that brace. Similarly, you need white space there. This should complain as well. Right. Again, it complains. Does it tell you, let's see. Mentioned syntax error was in this function, couldn't parse this brace group, fixed to allow more checks. Oh, so this one doesn't actually give you a helpful error message. So you need to know that there needs to be a space there. Oh, and I guess you need a new line, actually, not just a space. There you go. So remember, shellcheck.net, it's your friend. Okay, so here's an example of a bash function. Right, so we have a function called greet. Right, all it does is print hello. Right, to call the function somewhere else in your script, you just type in the word greet. So in other words, you treat the function as though it were a command. Right, and that's exactly how it behaves, including the input arguments for the function. Right, so to call greet, just write greet. Right, and it will call that script right there. Right, so if I run that script, it's just going to print hello. Oh, it actually prints 0. And why does it print 0? All right, I have to look at see what's going on here. Since bash scripts functions. Why is there? Oh, okay. So I'm printing. Oh, yeah. Okay. I see what's going on here. We'll come back to that in a second. All right. So when you call a function, it's exactly like calling a command. So functions can be commands in Bash as well. Right? If you have a bunch of functions in a script file somewhere, it's possible to call those functions from another script. I don't actually ever show you how to do that, but it's possible to do. Okay, now you can in fact pass arguments to a function. Right? Now, unlike other programming languages, the parameters of the function aren't named. So when you write your function here, test, right? Test has 3 parameters, but you don't put any parameter names inside the brackets. Right? So there's no naming of parameters in a Bash function. Instead, what happens is the positional parameters get recycled. Right? So inside a function, $1 is the first argument passed to the function. $2, second argument passed to the function. $3, third argument passed to the function, and so on and so on and so forth. The positional parameters 1, 2, and 3 for a function do not replace the positional parameters 1, 2, and 3 for the script. Right? So in other words, they're independent. Right? If your script has command line arguments, they're still there. Right? When you call the function, it's just that the names 1, 2, and 3 are reused for the arguments passed to the script to the function. Right. So here's a function called test. Right. Param1 is $1. Param2 is $2. Param3 is $3. Right. So in other words, those are the first, second, and third command line arguments passed to the function. Right. If you call the function, so if I call test with no arguments, right, $1, $2, and $3 aren't set. So param1, param2, param3 become the empty string. Right. So when you print them out, you get param1 equals empty string, param2 is empty string, param3 is empty string. Right. If you call it with one parameter, $1 is set, but $2 and $3 aren't set, and so on and so on and so forth. Right. If you call it with too many parameters, right, that fourth parameter is lost to the function. Right. So in other words, the function in this case isn't using it. Right. So $4 is set, but the function here is not using it. Oh, and then here I'm going to check if I pass any arguments to the script, I'm going to show you that those are in fact still intact. Okay, so we're going to call that script right here. So I'm going to call the script. I'm going to pass in 5 command line arguments to the script. Inside the script is going to call test, but it's going to call test with its own. It's going to call the test function with its own arguments, A, B, C, and D. Right. Inside test, $1, $2, $3, first, second, and third parameter arguments passed to the function, but they don't overwrite any of the command line arguments passed to the script. Right. So this thing here, when we run it, it's going to be very slow. Sorry. Oh, actually not so slow. Right. So when we call test the first time with no arguments, right, it tells you no arguments are passed to the function. Right. Param1, param2, param3, they're all empty. One argument passed to the function. Param1 is A, right? The other 2 are empty. 2 arguments passed to the function. Param1 and param2 are A and B, right? Param3 is empty. 4 arguments passed to the function, so the D is lost to the function, although the function has access to it. We're just not using it, right? So the 4th argument D is $4 inside the function. Notice that the command line arguments passed to the script directly are not overwritten, right? So they're still intact. You still have access to them. Right. Similarly, if there was a second function inside the script, $1, $2, $3, etc. for the second function, don't replace $1, $2, $3 for the first function, and so on and so on and so forth. So, I mean, the function behaves exactly as though it were a command, right, or a script, right? If you call the function with the wrong number of arguments, you get no error, unless you're detecting the error inside the function, right? The script will run. If there's too few arguments, any of the missing arguments are just the empty string. If there are too many arguments, the extra arguments are ignored. To get the number of arguments passed to the function, it's the same way that you get the number of arguments passed to a script, right? It's $number. Okay, so that's calling a function. What about returning a value from a function? So returning a value from a function is weird in Bash. So a function behaves exactly like a command. So what does a command do when it finishes? It sets an exit status. So what does a function do when it finishes? It sets an exit status. Right. So the exit status is always it's always an integer value, and it's always between 0 and 255. So you could, in theory, return a value, an integer value from a function, as long as it's between 0 and 255. If you want to return something else from a function, you have to do it in a very strange way. Okay, so here's some function. Right, it's going to, what's this do? It tests, it randomly sets its exit status to 0 or 1. Right, so in other words, so it calls, it looks up the random variable, right? Checks if it's divisible by 2. If it is, it returns 0. Otherwise, it returns 1. Right, so return inside of a function sets the exit status to the specified value. Right, so return 0, exit status becomes 0. Return 1, exit status becomes 1. If you run this, oops, sorry. If I run this, I don't know what's going on with my computer today. All right, so this time it printed 1. So the exit status is 1. If you run it again, 1. One more time, I'm going to go for 0. If I don't get 0 this time, I'm just going to give up. Oh, what happened? Oh, 0. There we go. Good. Okay, so that one sets the exit status of the function. Right? How do you get the exit status? It's $? Right? The exact same way you get the exit status of a command. Okay, so if I can't return it, if I want to return something other than an integer between 0 and 255, then one way that you can do this, which is very strange, is to print something on the last line of the function. Right. So here's max2. Right, so max2 returns the larger of its 2 arguments. Right, and the way it returns the larger of the 2 arguments is it prints the larger of the 2 arguments. Right, so it's, in other words, it prints the result to standard output. So if a command behaves, sorry, if a function behaves exactly like a command, how can someone that calls that function capture the result? Well, you use a command substitution. So right here is where I call max2. Right, so max2 prints its result to standard output. Right, so I can call max2, right, and then I can capture the output using a command substitution. Right, so $round bracket, call the function inside. Right, max2 will run. It prints the larger of the 2 values, but the output is captured by the substitution and stored in the value high, variable high. Right. Strange but true. Right? So this is one way that you can actually return something from a function. Right. You print it, and then you use a command substitution when you call the function. What does this actually do? I forget what the script does. Let's see. Okay, so if there's no arguments passed to the script, it exits with an error. If the input argument is an int, oh, I see. It's going to check the 2 input arguments. Okay, so there's also a function called isInt. IsInt returns sets the exit status to 0. If the argument passed to the function is an int, sets the exit status to 1. If the argument is not an int, so here we check, is the first command line argument an int? And then it looks at all the other command line arguments. So if the next command line argument is an int, it's going to compute the max of those 2, right? And it's going to repeat processing all of the command line arguments. And so it's going to find the maximum value of all the command line arguments. We're also using shift here to shift the command line arguments. Right. So that's a very convoluted way of computing the maximum value of 1, 5, 7, and 4, which is 7. there is a big disadvantage to doing it this way. So sometimes you can't do it this way. It won't, when you use a command substitution, it doesn't work properly. The reason it doesn't work properly is because when we call max2 here, right, what the shell does is it spawns a subshell, because this is a command substitution. So it always runs the command in a separate shell, right? So the command runs in a separate shell, does its output, the output's captured, and then returned back to the current shell. So that is expensive, right? So spawning that subshell is expensive, especially if you're just comparing the maximum of two values, right? So that's inefficient. There's also situations where if you run something in a subshell, you don't get the correct result back in the original shell. So you have to be a little bit careful when you do it this way. So instead, do I have time to talk about this? The way it's normally done is you normally take advantage of the way that Bash scopes its variables, right? And the scoping of Bash variables is very different than what you're used to. So Bash uses what's called dynamic scoping. Right? So what that means is it's uncommon in modern programming languages, right? But Bash being a very old scripting language, it's not surprising that this is here. All right, so how does dynamic scoping work? So in dynamic scoping, visible variables, so variables that are in scope, and their values are a result of the sequence of function calls that caused execution to reach the current function. So what that means is if your script body starts and it makes a variable A, right? Then that variable A and its value are available everywhere after that point of execution. So if your script now calls a function, inside that function can access A. If a function makes a variable B, and that function calls some other function, that second function now has access to the variable B. And furthermore, the main body of the script also has access to the variable B. Right? So variables appear as the script runs. And everywhere after that point, that variable and its value are available to the rest of the script. So, for example, here I've got a function f, right? I've got a function g, and I have the main body of the script. Right? So in the main body of the script, this is where the script starts running, right? So A gets set to hello. Right? Then we call f. Inside f is allowed to use A, right? Because it was called from the main body of the script, and the main body of the script set the variable A. It can change the value of A right there. And then it can call G. Right? Inside G, A is available to it. Right? G can make a variable called B. Right? And then we come back to F. Right? F can now use B because it called G. Right? So you have to trace the sequence of events that happen in order to figure out what variables are actually available to you. What makes this difficult is that Bash automatically creates the variable for you. So if you think that there's a variable that you should be able to use, but it actually isn't, then when you use it, you end up with the empty string and you don't get a warning. Right? Strange, but true. Right? So if you actually run this thing, it does in fact work. Right? So A before calling F, so it's hello right there. Right? At the beginning of F, it's still hello. Right? At the beginning of G, it's still hello. At the end of G, A is still hello. And at the end of F, it's still hello. Right? A after calling F is hello. B after calling F is goodbye. Right? So if you trace through this sequence of calls, you can figure out that this is in fact the output that you want, that you should expect to see. Right? Oh, I actually traced it through for you here. Right. So at some point, take a look at this notebook and read those steps there to figure out what the heck is going on inside the script. Right. But because you can take advantage of the fact that Bash, the variables become available as you use them. Right. In order to return a value, you don't really return a value. Right. So what you do is in the main script, you make a variable, whatever you want to call it. And then in the function that you call, you just set the value of that variable. right? Then when it returns, your main script now has the value of that variable available, that variable now set for you. So that's the other way that you can return a value from a script. Right. So dynamic scoping can be used to simulate returning a value or values from a function in different ways. So you can assign the return values to variables that were visible to the caller, right? So in other words, whoever calls the function makes some variables, call the function, and then inside that function, it sets the values of those variables, right? Or you can create new variables and assign the return values to the new variables, right? Now the caller has access to those new variables, right? So in other words, your function can create a variable called, I don't know, my return value. And then inside the rest of the function, you can now use the variable my return value. And so I'll just leave it there and we'll finish this up, I guess, in the next lecture. Yeah, we have to talk about one more thing. And that'll be it for Bash. Right. And then we're going to move on to the C part of the course. Any questions? All right. If you came in late, there is the assignment is out. And if you are having trouble debugging your scripts, use shellcheck.net. It will help you out tremendously. Yes.
Yeah, I have a question in this back from assignment 2. I just don't like, if you look back, you can see that I'm buying it for a while. I don't know what it's doing.